Hey guys, welcome back to my channel. In today's video, we are going to be discovering one-to-one functions, so let's get started. So, what is a function? So, as we know, a function is a special relationship between values. Every input has an output. X is the input and Y is the output. So, let's learn more about one-to-one functions. So, one-to-one functions, this is also called, in other terms, an injective function. This is where each input is paired with a unique output. So, for example, let's say at a party, there's one chair and there's two people. So, if two guests share one chair, then it's not one to one. But if only one person sits on one chair, then it's one to one. So how do we test for one-to-one? So there's two ways we can specifically test for one-to-one. So the first way is a graphical test. So this is where if you can draw a horizontal line, so like let's say this is our graph right here. So if you can draw a horizontal line from like your graph, that means that it is not one-to-one. Because if it intersects the graph at a function more than one point, then it's not one-to-one. This is also known as a horizontal line test. So the next is the algebraic test. If for every pair of inputs x1 and x2, where x1 does not equal x2, the outputs fx1 and fx2 are also different meanings. And also, if fx1 does not equal fx2, then the function is one-to-one. So this is just like a short definition of what I mean. I'm going to be showing you guys examples so you guys know what I mean by this. So our first example is fx equals x, and this is a one-to-one. How? Let's try it out. So the first one, which is our graphical test. So actually we'll do the second one first so I can show you the graphical test. So if we do an algebraic test, so what we want to do is we want to put we want to choose a number, actually a range of numbers that we can test that will give us a y output. So let's do -2, -1, 0, 1, and 2. And this is going to be our x, and this is going to be our y. So if you put -2 into x, so f -2, it's just going to be -2. So -2 here. If we have f -1, that's just going to be -1. And then if you see the pattern here, so it's just going to be 0, 1, 2. Now, if we were to graph this, right? So let's say we have -2, -1, -2, 0, 1, and 2. And this we have 1, 2, -1, and -2. So our x is -2, and then our y is also -2. Our 1 is -1, and this is also going to be -1. And our 0 is going to be 0, so it's going to be in the middle right here. 1 is going to be 1, 2 is going to be 2. And so if you draw the line here, this is our line. So we can see here that from our graph also, the x values have a different y values for each time. Notice how they're not all the same, right? So this is why it would be considered one-to-one. Now, if you wanted to do a horizontal test, swim blue, so we can draw a line anywhere where our graph is, and you can see that there's always just one point. So like right here, just one point. There's not another point, let's say over here, that makes it not one-to-one. Over here too, there's one point, one point, one point. So therefore, this is a one-to-one. Our next example is 3x plus 2. So let's start off again with our algebraic test. So we want to use different values. So I would say always use negative, at least 2 negative numbers and 2 positive numbers. That will really tell you where you have same values or not. So let's make another chart. -2, -1, 0, 1, 2. And now what we have here is, so -3 times 2 is going to be -6 plus 2, which is going to be 4. So then 3 minus 1 plus 2, that gives us -3 plus 2 is just -1. And then afterwards, 3 times 0 so that's 0, plus 2 is just 2. 1 times 3 is 3, plus 2 is 5. And then 2 times 2 is 6, plus 2 is going to be 8. Okay, we can see from here that also that all these x values have different y values, which makes it 1 to 1. And we can confirm this by drawing a graph. Okay, now we have here, this looks a little bit very like clustered. It's just I didn't have enough space, but I hope you guys know what I mean by this. So for here we have -2 and -4, so it's gonna be down here. -1 and -1. We have 0 and then we have 2 right here. Then we have 1 and 5, and we have 2 and 8. So if we draw the line, it's gonna be going like that. So you can see here that they all have distinctive 1 values. And now we're gonna try a horizontal test. So if we would pass it through here, we only are getting it at one place. So like right here. Then if we try it at another place, we're also getting it at just one place, right here. Right here. So this is why this is also a 1-to-1 function. Okay, so we have an example here, which is x squared. So now, this is not a 1-to-1 function, and let me explain why. So, first we're going to try is putting random variables and seeing if it has the same input or not. So, let's put -2 into our equation. This is just going to be 4. So it's 4 here. Then we're going to put f -1 is just going to give us 1, right? 0 is just going to be 0. 1 squared is just going to be 1. 2 squared is just going to be 4. So if you guys see right here, more specifically at -2 and 2, and then -1 at 1, they have the same y value, which a 1-to-1 function cannot have, right? So therefore, just by looking at this, we can already tell that it's not a 1-to-1 function. And so if we were to draw this, guys, to also prove it's not a 1-to-1 function, so we have -2 here, -1, 1, and 2. And this is, let's say, 2 and 4. Okay, so this is 1, 3. So -2 right here is going to go to 4. And then -1 is at 1. 0 is going to be 0. And then 1 is going to be at 1. And then 2 is going to be at 4. And if you were drawing this, it's going to be a parabola that goes upwards, right? And now if we want to do the horizontal test, we can go one right here. Let's say one right here. One right here. No matter where you go, look here closely. This part here is 1 point, and it's another point. So this has 2 different values that is being determined when it's a horizontal test. Over here too, there's 2 values here, 2 values here. So therefore, this is not going to be a 1-to-1 function. And one thing is that 1-to-1 functions are very important because they have inverses that are also functions. I'll be doing like a whole nother video about this where you can find the inverse function. It's very easy. You just replace the x with the y and then the y with the x, and you have to solve for y this time. But this was my little introduction on 1-to-1 functions. I hope you guys are understanding. Please let me know if you guys have any questions. I'll be more than happy to help you guys out. And thank you guys so much for watching.